Hi, so we will see how we can configure Relic to monitor our own Node.js application. So over here you can see that I have already configured a demo one application which is in Node.js and it's started monitoring. So we'll just see how I have done this. So what I will go to applications, and before creating an application I will just show you my Node.js project so that you get an idea what exactly I'm doing. So in this Node.js project, in my main.js, which is a Node.js application, my first line is require new relic. So basically this is a library which will help the new relic system to new relic client program to get basically get the monitoring details from the Node.js application and push it into a file which is then basically asynchronously pushed back to the relic system, new relic servers, which basically reading this input monitoring data develops some visual analytics for our purpose. So this is a include, and we need to configure our relic new the file is new relic.js, which basically takes the name of the application and the key. So I'll change my application to demo2 since I'm creating a new one, and to show you how I can create a new one. This is a license key, which is basically an authentication that my application which is sending the monitoring data is an authentic one. So it will basically accept this data as authorized from myself. So over here I'll do add more. So in the add more I'll click the type of application for which I want to do it. So it's Node.js. So I've clicked on it. Yeah. So over here I need to get my license key. Then I will do this is basically the steps, which is basically to install the new relic APIs. Then the steps which I told you, that the new relic.js file I need to mention the app name and the license key, the first line in the application that is required new relic, and then deploy my application and I can see my data. So in order to see that, I'll just mark this to as listen to my application. So it started listening to my application, but my application is not running yet. So what I will do is I'll up my Redis server first, that is Redis server. So the Redis server started and it's listening on port 6379, and I will start my main node main.js application also. So I've started the application, it's listening on port 3000, and I'll try to simulate a request. I have created a script for that, so it will just basically simulate a request. I just uncomment this line. So what it does is it's basically making a, a browser simulating a browser request, and it sleeps for 2 seconds and again simulate the browser request. So basically I'm just trying to load my Node.js application with some request. So I'll run this. So as you can see, it started loading it, and I can see I'm getting the browser request over here. So as per this, my application setup is done, and I should able to see the dashboard in some like within 5 minutes as per them. So I'll just clear up my setup page and go to the dashboard if I have to just to check if it's ready or not. So this is my demo 2, and my dashboard is not still ready, so I'll just wait for my dashboard to get ready. It will take like another 5 minutes. I'll pause the video till then. Hi. So as you can see, my stats has been started captured by the new relic system, and over here I can see various stats such as the time spent in the Node.js application, or the time spent in the Redis, or the response time of the application. So this is like a time series data, so it just tells me the response time at different interval of time. Over here I can also see the AppDex score, which is basically the when I click here you can see the AppDex value. So it's basically the average response time. So if my response time is, if currently it says to 0.1, so what happens is like any response time which is below 0.1 is considered as a satisfied one, and basically there are different thresholds, like from 0.1 to 0.4 are considered as tolerating, and another ones are considered as frustrating. In order to that, we also get the throughput of the system, that is the load on the system during different interval of time. If I go on over here transactions, I can get the different types of transaction which is being done on this particular web server application. So I can see that my most of the load will consist of mu handle, which will basically get the image from the Redis server and display it another one is like the list server. So over here I can just see the load for the different particular operations over here, list server, get or mio. This is again the throughput of the system. If I go to the database section, I can see that let is and lrange is the operation which is taking the most time, that is 6 milliseconds. So over here basically I get various aspects of my Redis database application, the response time, the average response time, and basically I can set up your alerts if to set some threshold, and if my suppose my application is not responding, or if my application is not up, or I'm getting a lot of 404 errors, I can set different kind of alerts and generate errors for that, so that I can generate an error analytics report for that. So this is just a brief overview of how I can basically connect my application to New Relic system and start monitoring it. Thank you.
To demonstrate the server monitoring capabilities, I've created two new VMs on DigitalOcean, called them New Relic 1 and 2, and also configured them to send the data, essentially the system metric data, back to New Relic. And we could click on one of the VMs and get more detailed information about essentially the CPU utilization and the I/O that's happening, both disk and network. For instance, as you can see, we displayed the CPU usage as a percentage from 0 to 100, and essentially a load factor, and also the amount of physical memory that's being used historically, the disk utilization, and the network, essentially the packets going in and out of the system. Another important metric that's also being collected is essentially information about the processes that are running on the machine. For instance, as you can see, it shows us the top 5 memory consumers, and if you look at this particular metric, a particular process, this is the daemon that is collecting the data and sending it back to the servers. As it turns out, the CPU usage is pretty less, and so is the memory usage. So it looks like the memory footprint of the daemon that is collecting and sending out the data is pretty small. Similarly, we can get more detailed information, essentially historic information, about the network and the disks that are there on the machines. For instance, we could get the number of packets sent out, essentially the number of packets dropped, and other useful metrics like this. Similarly, on the disk side, we could get the number of IOPS and essentially the storage that's being used, amount of available space, etc. Just give it a moment to load. Yeah, the IO rate, the IOPS per second, etc. I'll just quickly guide you through the process of creating a new VM and essentially configuring it to send back data to a New Relic dashboard. To do that, I'm just going to create a new VM on DigitalOcean. Let me just go ahead and do that. Let's just pick Ubuntu, and yeah, any size should work. And we'll just call this test machine. Create. And let's just go back and add another VM to the list of machines that are being monitored. Here we select the platform that we're running on, in this case Ubuntu. The monitoring services provided on a whole bunch of different OSs, including Red Hat, CentOS, Windows, etc. In our case, we're going to pick Ubuntu, and it displays a list of instructions that will have to essentially run on a VM to set up monitoring capabilities. Now that the VM is created, I'm just going to log into the machine. And set up we're just adding a new repository to our Linux machine that we just created, and here we're installing the sysmon d daemon, which is essentially the daemon process that runs in the background and keeps collecting metrics that it later sends to essentially the New Relic cloud. This step lets us configure the daemon by setting a unique license key, which lets the service uniquely identify. And finally, we just run an initd script to start the daemon. Yeah. As you can see, yeah, that's about it. And this is the set. This is all the steps that are needed to set the VM up to essentially collect the data and send it back to this cloud. Now we're just going to go back to our server dashboard and see if, I mean, this usually takes a couple of minutes. We're going to see if the data populates. As you can see, the new machine called test machine that we just configured has showed up on the list of servers. Yeah, this takes a couple of minutes for the data to populate, and yeah, as you can see, some of the data has already showed up. The CPU, the type of OS it's running, etc. While the time series data has not been loaded yet. This usually takes a couple of minutes, and yeah, we'll just pause the video for a while and come back in a while and show you the results of this. As you can see, after a couple of minutes, the time series data has started to come in as well. Essentially, you can notice the load and the memory usage and the disk utilization, network I/O ever since the VM has been created just a couple of minutes ago. The data is essentially collected by the daemon and sent in every minute, and we see the data being updated on a minute by minute basis, although the resolution is much finer than 1 minute. And that's about it on the server side of things.